Hello students, today let us discuss something about the projectile motion down an inclined plane as a special case for the application of the equations of one-dimensional motion in two dimensions. Okay, let's discuss now. So we know that along the one dimension we have the equations of motions as v is equal to u plus at, and another one is s is equal to ut plus half at square, and as you know, then b square is equal to u square plus 2 times as, etc. But these equations of motions are applicable only when the particle is moving along the one direction. Okay, but these equations of motion can be used in two dimensions also. But how? As a special case of that, let's discuss the projectile motion down an inclined plane. Okay. Let's assume that this is the inclined plane. I am projecting the projectile from this point, say its initial velocity is u, so it will be flying along this path, okay. So I want to draw this for simplification and for easy analysis. I want to draw this particle horizontal here. This is the horizontal. Okay. Another horizontal is drawn from this end like this. Okay. So this inclined plane makes an angle alpha with the horizontal. Okay. And this projectile is projected making an angle theta with the horizontal. And now this line is parallel to this line, and this is the transversal. Therefore, this angle should be equal to this, that means alpha. Now we know that this projectile is moving under the influence of the gravitational force. Therefore, the acceleration involved is the acceleration due to gravity. Okay, so first we should take the components of the acceleration of gravity along the different axes, and we will find out the time of flight and then the range, etc. So to find it out, let's draw the let's assume that this is the x-axis and this is the y-axis. This is the y-axis. Now we know that the acceleration due to gravity is acting along the center of the earth. Therefore, g is vertically downward. Okay. Okay, so to find out this component along the y, I want to draw this a line parallel to y-axis. It's like this. Okay, along the x, no need to draw. Okay, just one arrow is there. Okay, now I'm extending this. Here the angle made is 90 degree, and also this is y prime. This is x. Therefore, the angle here also 90 degree. Okay, therefore, and at the same time, the angle of let this small angle be say small x, and this small angle will be small y. Okay, therefore x plus y is equal to 90 degree. X plus small y is equal to 90 degree. At the same time, alpha plus small x is equal to 90 degree. That implies this y is equal to alpha. Therefore, this angle is equal to alpha. Therefore, the component of acceleration along the y-axis is g cos alpha with a sign negative, because it is acted along the negative direction of the y-axis, and along the x-axis it is g sine alpha. Now let us find out the time of flight. To find it out, let's first write the components of the velocities along the x and y-axis. Now along the x-axis, component of the initial velocities ux is u sine theta plus alpha. Okay, and along the y-axis is uy is equal to u cos, along the x-axis is u cos theta plus alpha, and along the y-axis is u sine theta plus alpha, and component of the acceleration along the y-axis is minus g cos alpha, and along the x-axis is g sine alpha. Now, to find out time of flight. Time of flight means the time during which the projectile will be in the air before falling, before striking the ground. Okay, time between the point of projection and point of hitting the ground, that we call the time of flight of the projectile. So to find it out, okay, as you know, when the projectile reaches its midpoint of this path, say here, its final velocity along the y direction is 0. That means By is equal to 0. Okay, now, okay, so before applying that equation, let us say one thing. Time of flight is equal to time taken to fly upwards plus time taken to fly downwards. These two durations are the same. So time of flight is equal to 2 times t half, maybe up, maybe down. So v is equal to u plus at, implies b is the final velocity along the y direction 0, ui is equal to 0, by is equal to ui plus ay t half, implies final velocity along the y direction is 0 plus is equal to initial velocity along the y direction is u sine theta plus alpha, and as acceleration is minus z cos alpha into t half. Therefore, time taken to travel half of this part is equal to u sine theta plus half plus alpha divided by z cos alpha. Therefore, time of flight, total time of flight, capital T, is equal to 2 times of t half is equal to twice u sine theta plus alpha divided by z cos alpha. This is the time of flight, expression for the time of flight for the projectile under projectile on an inclined plane. So let's find out range. Okay, to find out the range, we need to use a trigonometrical formula. The trigonometrical formula, let me write it down first. In the side, say, okay. So the trigonometrical formula, let's write it down here. We know that sine of a plus b is equal to sine a cos b plus sine b cos a. Or if the angles are equal, then sine a plus a is equal to 2 times sine a cos a. And again, cos of twice a is equal to cos square a minus sine square a, implies twice sine square a is equal to 1 minus cos twice a. Cos twice a. Okay. We need to use these formulas to find out the range. Okay. Let's come to side. So to find out the range, that means that is distance travel along the x-axis. Okay. We need to use the equation of motion, like the equation of motion is x is equal to uxt plus half of a t square. Okay, so for the range, time taken should be total time of flight. Okay, therefore range r is equal to ux is u cos theta plus alpha into capital T plus half of a. A is how much? Is along the x direction, so z sine alpha and capital T square. Okay. Let's analyze that. So it's equal to u cos theta plus alpha into capital T is twice u sine theta plus alpha divided by z cos alpha plus half of z sine alpha capital T square is how much? So 4 times u square sine square theta plus alpha divided by z square cos square alpha. So I'm taking common here. What terms can be taken? Okay, I'm taking u square sine u square. Okay, u square divided by z cos alpha. Z cos square alpha is taken common. What terms are remaining inside? So here is twice cos theta plus alpha into sine theta plus alpha into cos alpha. Okay, minus. Okay, plus. Sorry. So it must be okay sine alpha, then twice sine square theta plus alpha. Okay, using this equation I am analyzing the first part, so simplifying the first part. So it must be z u square by z cos square alpha, then here comes sine of 2 times theta plus alpha. Okay, then cos alpha plus sine alpha, then twice sine square theta plus alpha. I am simplifying this part using this formula, then it comes 1 minus cos of twice theta plus alpha. Then what terms are remaining? So okay, I can write down here u square divided by z cos square alpha, then comes sine of sine 2 theta plus alpha, then sine alpha cos 2 theta plus alpha. So what can I write? Sine A cos B. Okay, and then sine B cos A minus. So sine of twice theta plus twice alpha. Okay, then minus of alpha. Okay, plus sine alpha. This is the expression. So the last expression should be u square divided by z cos square alpha whole into, let's write down here. It must be equal to u square divided by z cos square alpha whole into sine of twice theta plus alpha plus sine alpha. This is the expression for the range. Okay, but there is another case, another term called maximum range. For that maximum range, this is the range. This is the expression for general expression for the range. But the maximum range, there is another term called maximum range, which says that under what condition the range should be maximum. Okay, for an inclined plane, this alpha, this angle of inclination is constant. Therefore, what can be the variable? That variable can be the theta. So what the variable will be in this sine 2 theta plus alpha term. So this range will be maximum only when this variable gives the maximum value. This variable sine function gives the maximum value when its value is equal to 1. That means for the maximum range Rmax, the expression will be u square divided by z cos square alpha whole into 1 plus sine alpha. This must be the expression for the maximum range. So, and I want to find out some relation between the angle of projection and this alpha term. Okay. Under what condition we get the maximum range? So we have already known that the maximum range will be obtained when this argument, this angle is equal to pi by 2, because sine gives the maximum value, sine function gives the maximum value when the angle is equal to pi by 2, implies this theta will be equal to pi by 4 minus alpha by 2. Okay. When the angle of projection is equal to pi by 4 minus alpha by 2, the projectile under consideration, that means the projectile on an inclined plane will move along the will be traveling the maximum range. Okay, that means when this angle of projection is equal to 45 degree minus this alpha divided by 2. Okay, when the projectile angle is equal to 45 degree minus alpha by 2, the projectile will be moving the maximum range. Okay, thank you friends. Up to this we want to discuss for today. Thank you. Let's wind up.